Welcome to the intelligent world of data structures and algorithm. In this introduction to DSA video, we will delve into the art of efficient data organization and problem solving that powers modern technology. This course will get you started with data structure and algorithm and help you to master them from the basic. Understanding what is data structure and why do we need it, understanding algorithms and related concepts. Getting hands-on with some most common data structures such as arrays, linked list, stack, queue, and understanding how they work. What is the target audience? User who wish to learn about how data can be efficiently stored and processed via algorithms and want to get better at programming. So let's get started. Bad programmers worry about the code. Good programmers worry about data structures and their relationships. Well, even though computers can perform millions of mathematical computations per second, when a problem gets large and complicated, performance can nonetheless be an important consideration. One of the most crucial aspects of how quickly a problem can be solved is how the data is stored and fetched from the memory. It is believed that data structures and algorithms are the basics of computer science. It is actual computer science. Any developer or CS student must write code that provides a required output. Algorithms are methods to implement certain tasks, while data structures are like hands for algorithms to make a recipe. Using a combination of data structure and algorithms, we can improve the performance of program drastically. Let's understand through an example. Once a fox invited a crane for a dinner. The crane was joyful, but the fox only wanted to insult the crane. When the crane arrived, the fox served it a bowl of soup. It smelled delicious, but the crane's beak was ill-suited for a bowl. It could only snap its beak in frustration. Meanwhile, the fox lapped off the soup in minutes. The crane's algorithm to pack food was working on the wrong data structure. The crane gave up and took the fox's leave. However, before leaving, the crane invited the fox to dinner at its place. The fox immediately accepted. At the crane's place, the fox was served some fish in a jar. The fish waited invitingly at the bottom, which was out of the fox's reach. On the other hand, the thin jar opening was perfect for the crane. It packed out fish with ease. That's what happens when you use the right data structure. An algorithm is a procedure that completes a task like eating fish. A data structure defines a contract for storing, retrieving, and manipulating the data inside it. Choosing the right data structure for an algorithm is critical for its success. Next topic, data structure. What is it? Introduction. Since we live in the age of data, it's a good idea to familiarize yourself with the best way to handle and organize information. More importantly, if you want to become a software engineer or a related data science professional, you need to understand concepts like data structures and algorithms. In this section, we are going to understand data structure concepts, including the definition and importance. To understand data structure, we must first understand data. What is a data? In the modern world, data and its importance is an essential part, and various implementations are being made to store in different ways. Data is just a collection of facts and figures, or you can say data are value or a set of value that are in a particular format. A data item refers to a single set of value. In every programming language, we have some data types. For example, we have some data which has player's name Max and age 28. Here, Max is of string data type and 20 is of integer data type. Suppose you go to the library and want to find a book on the 5th edition DSA. You have to go to the CS section. From there you will find the designated area set aside for DSA. Then go through the books sorted in the chronological order until you find the 5th edition. Now consider books as your data and the library's method of sorting the books as the data structure, and you are all set. In short, a data structure is a specific means of organizing data in a system to access and use. Let's have a look at the technical definition. Defining data structure. Data structure can be defined as an arrangement of a collection of data items so that they can be utilized efficiently and the operation of data can be done efficiently. Therefore, data structure is all about the arrangement of data and efficient operation on the data. But the question is, where is it used? The answer is inside the main memory during the execution of a program. Every application will have a set of instructions that perform operations on data, so data is mandatory. Here is the question. Data structures are the structure programmed to store order data so that various operations can be performed on it easily. Tell me the answer. Select the correct answer out of true or false. So the correct answer is going to be true. Now check the result. Yeah, correct. Next topic, types of data structure. Here is the flowchart of types of data structure. You can check out. You can see here is the flowchart of types of data structure. Primitive data type. Primitive data types are the data types available in most programming languages. These data types are used to represent single value. It is a basic data type available in most programming language. Here is the primitive data type. Integer, used to represent the number without a decimal point. Float, used to represent the number with a decimal point. Character, used to represent a single character. And Boolean, used to represent logical value either true or false. So this is all about the primitive data type. Now talk about non-primitive data type. Data types derived from primary data types are known as non-primitive data types. Non-primitive data types are used to store group of value. Non-primitive data types can be divided into two types: linear data structure and non-linear data structure. So first we will talk about linear data structure. A data structure is said to be linear if its elements combine to form a specific order. In a linear data structure, only one data element can directly be reached. The common example of the linear data structure are array, linked list, stack, and queue. Now, non-linear data structure. In non-linear data structure, the data values are not arranged in order and the data item is connected to several other data items, like see in figure. Several other items connected in non-linear data structure. This structure is mostly used for representing data that contains a hierarchical relationships among various elements. It includes trees and graphs. Now we'll talk about why data structure. Companies sell software to do more business. Amazon makes money from e-commerce, AWS. Microsoft makes money from Windows. Google makes money from ads, etc. How does a company develop software? Well, by software developers like who you code. What is coding? It is writing an optimized program using some language to achieve some task. How to write an optimized program? By learning data structure and algorithms. See, here you can understand the chronology. Next topic, what is an algorithm? You want to master this course, right? That means you want something done. Find a method or steps that will help you to get your work done. We call this method algorithm. In simple terms, algorithm is a step-by-step process followed to do a complex any task. The best real-life application of the algorithm is you and me. That is the common man. Step 1. Start. You were born with a beautiful personality and came into this beautiful planet called Earth. Step 2. Happiness all around. Your entire family was happy with the aroma that came along with you. Step 3. Learning to walk and talk. You learn to walk, talk, run, laugh by failing so many times. Step 4. Join a school. You join the school to get a quality education and learn what discipline is. Step 5. Learn to hold a pen and write. Excitement creeps in and you get a small joy while you holding a pen writing for the first time. Step 6. Years pass by. Few years down the line you realize that it is time to give exams and score good marks. Step 7. End of school. Your life as young ends and you step into the college to see the real world and people. Step 8. College. You meet so many new people. You may join a course or choose a stream which you hate, but apart from that, you will get enough time to party and have fun with new friends. Step 9. Career. Our fantabulous days are over now. We will get to know what politics is in our workplace. We will need flatters. Step 10. Face rejection and disappointment. Think of steps 1 and 2. Forget the disappointment and move on. Step 11. Gets old. Enjoying your time with your loved ones. Step 12. There is an end in life. In the end, you are with the God. This is how the common man's life looks like. All this is nothing but an algorithm of an every common man's life. Defining the algorithm. Now let's define the algorithm with technical definition. And algorithm is a set of well-designed step-by-step instructions designed to solve a problem or perform a specific task. An algorithm is not the complete code or program. It is just the core logic solution of a problem, which can be expressed either as an informal high-level description, as pseudocode, or using a flowchart. Suppose you want to add two numbers. The steps are crystal clear and there is no doubt. First take number 1 and then take number 2 and then add number 1 and number 2 as shown in the value image like this. Step 1, step 2 and step 3. Now here is the question. An algorithm is not the complete code or program. It is just the core solution of a problem. Select the correct answer, true or false. So this is absolutely true. Check the result. Yeah, correct. Categories of algorithm. From the data structure point of view, the following are the some important categories of algorithm. Search. Algorithm to search an item in a data structure. Sort. Algorithm to sort items in a certain order. Insert. Algorithm to insert items in a data structure. Update. Algorithm to update an existing items in a data structure. Delete. Algorithms to delete an existing item from a data structure. Characteristics of an algorithm. Not all procedures can be called an algorithm. An algorithm should have the following characteristics. Input. An algorithm has some input value. We can pass 0 or some input value to an algorithm. Output. We will get one or more output at the end of the program. Unambiguity. An algorithm should be unambiguous, which means that the instruction in an algorithm should be clear and simple. Finiteness. Algorithms must terminate after a finite number of steps. Effectiveness. An algorithm should be effective with the available resources. Language independent. An algorithm must be language independent so that the instruction in an algorithm that can be implemented in any of the languages with the same output. The complexity of algorithm. Time. How do you measure your code? Would you clock how long it takes to run? What if you are running the same program on a mobile device or a quantum computer? The same code will give you different results. To answer this question, we need to nail some concepts like time complexity. Time complexity. The time complexity is not about how long the algorithm takes. Instead, how many operations are executed. The number of instructions executed by a program is affected by the input size and how their elements are arranged. Time complexity or running time is the estimated time an algorithm takes to run. However, you do not measure time complexity in seconds but as a function of the input. Why is that the time complexity expressed as a function of the input? Let's find out. Let's say you want to sort an array of numbers. If the elements are already sorted, the program will perform fewer operations. Unfortunately, if the items are in a reverse order, it will require more time to get them sorted. The time a program takes to execute is directly related to the input size and its arrangement. We can say for each algorithm have the following running time. First case time complexity. Example, input elements in reversed order. Base case time complexity. Example, already sorted. Average case time complexity. Example, elements in a random order. We generally consider the worst time complexity as it is the maximum time taken for any given input size. So it's time to revise. So let's revise. Fill in the blanks. Every application will have a set of instructions that perform operation on. Choose the correct answer to fill in the blanks. Think what will be the correct answer. I think data. Check the results. Yeah, correct answer. Next question. The linear data structure includes linear stack linked list array is the right answer, I guess. Yeah. Data types derived from primary data types are known as non-primitive data types. Yeah, correct. True. Yeah. Characteristics of an algorithm. Unambiguity, finiteness, speed, language independent, output, input, all are there. The characteristics of an algorithm. Yeah, correct. Fill in the blanks. We usually care more about the complexity as it the maximum time taken for a given input size. This is worst case time. Congratulations on taking your first step into this limitless universe of DSA. Embrace challenges, dream big, and together let's shape a future fueled by the innovation and curiosity. Happy exploring. And last, thank you for watching. If you found this channel helpful for your studies, consider subscribing and supporting us. Your subscription will definitely assist you in your academic journey. So hit that subscribe button and show us your support.